This is lecture 33, where it'll be a fairly quick lecture because we're just going to show you the obvious extensions of our 2D point groups. So this is without using anything but just single rotations and not even using the rotation relationships that we developed through Euler's formula in the last couple lectures. So this is just to catch us up, to put the first ones on the chart, and then after this we'll then develop the other multi-rotational ones. So I'm showing you right here are the 3D point groups that are just based only on a rotation axis, or not, because number one over here, which is absolutely nothing, is just no rotation. So the point groups here are being represented by a point in space, which you can imagine is in the center of a sphere. And this is actually a sphere, not a circle. And what they're trying to show you is the motif type that would be induced on this sphere. Okay, and you could see that and excuse my not being able to center this with the PowerPoint. That's what that is. I didn't take it off the grid, so I'm dropping it exactly in the point. So this should be at the center, but I think you can figure that out. So these are just my little primitive PowerPoint versions of some of the ways that people represent things. So this one here, it's just saying, look, I literally have this object on a sphere, and it just sits there. There's no rotation axis. There's nothing. It's one, right? So these are the first 1, 2, 3, 4, 5 3D point groups, and all they are is the rotation axis essentially. So here you can see this again. If I have a point on a sphere and I rotate about this axis, which is a twofold axis, I end up with just a point over there. And again, this is a sphere, right? You got to keep that in mind. So the right one, for a while, I'm going to stop drawing these when they get like super complicated, because as you can tell here, I can barely paste them in and do things appropriately. But I wanted to just point out how these work, because we'll be using them as we go up. And then I'll show you, I'll scan in a representation of all of the 3D point groups eventually, so I don't have to draw them. But you can see here that the left one is sort of the motif demonstration, and the right one is going to be the symmetry elements. So this just says it's a sphere and it's got a single twofold axis popping out. Let's say it's the pole that goes through the Earth here, and it only has a twofold axis. Now, what we're going to do later, as you can see down here, the other symbol we're going to use is going to be an open circle, and that's going to show something on the other side of the sphere, right? So for example, suppose I want to make this blue line a twofold axis as well. You can imagine this dark black dot represents something on this side of the sphere, and so going through it around a twofold rotation would be an open circle on the other side, showing that it's on the other side of the sphere, right? So that's going to be, of course, these are all on the same side because we don't have any operation to bring them over, because we're putting the axis right in front of us. You need another axis sort of on the side to start to rotate these things onto the other side of the planet here. So just finishing this off, the threefold axis, pretty straightforward. We now have a threefold axis, which means that these are all 120 degrees apart, the motifs, all on the same side of the sphere, let's say. And then the fourfold axis, just a simple symmetry element, again, shooting through the pole of the sphere, and therefore just rotates 90 degrees, the same motif. And then, of course, for the sixfold axis, same thing. I have a sixfold axis shooting through the sphere, and then all I have is these six things. And remember, these are point groups. We haven't inserted them in anything. We're just beginning, just like we did with the 2D point groups. We just wanted to show you that the number of point groups increases now that we have 3D, because we have inversion and things like that. So originally, we're going to be able to go up to a larger number because we have all of these, we have a little bit more flexibility, right? But these are the first 6 3D point groups.